Now move to theorem 7.
Yes, sir. It's
Okay.
that's theorem.
Theorem 7 now. So theorem 7 says opposite angles in a cyclic quadrilateral sum to 180 degree. That's theorem 7. Opposite angles in a cyclic quadrilateral sum to 180 degree. And what does that mean? This is what it means. You have a cyclic quadrilateral is having a quadrilateral in a cycle. So you have a cycle, and embedded in that cycle is a quadrilateral. So if I may ask you, what is a quadrilateral?
A shape with 4 sides.
God bless you. A shape with 4 sides. That's good. So you have this inscribed in that circle. And we have the angles to be A. Sorry. I don't want it to overlap to the other side. So this is A. This is B. This is C. And this is D. So by the theorem that we just stated now, said opposite angle in a cyclic quadrilateral. So A is directly opposite to C. So that means A plus C equals 180. That's what that theorem is saying. Similarly, B and D are opposite each other. So B plus D equals 180. Is that clear?
Yes, sir.
So opposite angles in a cyclic quadrilateral sum to 180 degree. So please write that quickly, draw, and let me know when you're through.
Yes, sir. I'm done, sir.
Okay. Now, note, it is possible to have two quadrilaterals in a cycle. Do you understand that now? It's very possible to have two. In one of the questions I'm going to give you to do, we're going to have something like that. So let's see examples. So I want you to, okay, let me move to new page, or should I manage this side? Let me manage this. Let me manage this. So example. So the question says you should find K and L. Find K and L in the figure above. So draw that quickly and use that theorem now to find K and L. So we can say this is example 1. Are you true?
Yes, sir.
So what did you get for L? What did you get for K? I can't hear you.
Um, for K, I got 60.
Okay. That's correct.
And
Easy.
and for L, I got 36.
Correct.
Thank you.
So let's see the second one.
Sir?
The second example. That's what I'm trying to put up now.
Oh.
The whole of that angle there is 97. This angle here is X. This angle here is Y. And this angle here is Z. And this is the center of the circle. So the question now says, what are the values of X, Y, and Z? What are the values?
Is Z 83?
Correct.
Let's see. Need to find wow. Z. Do we use another circle theorem in this?
Exactly. You combine as many as possible theorem to solve problem. As many as possible. So looking at it closely, which other theorem do you think would be appropriate?
Oh, angles in the same segment. Oh, is this angle in a semicircle is a right angle?
God bless you. And that's why I've told you that this is the center. This is the center. Very good. So you are going to use cyclic quadrilateral by saying Z plus 97 is 180. Now, I've told you anytime you use any theorem, it's always important to state the theorem you have used by putting it in brackets. You get that now? So in this case now, you just say opposite angles in cyclic quadrilateral and blah, blah, blah. So that is how you have obtained your Z to be 83. Now, since you have been told that this is a center and you know that this is going to be a semicircle, so X equals to 90 degrees, you will now put in bracket angle in a semicircle is 90 degrees. So that answers that. Now, if you now use opposite angle in a cyclic quadrilateral, that's X plus Y equals 180. We also state that too, opposite angle in a cyclic quadrilateral. And that will be Y equals 180 minus 90, which is also 90. Is that clear?
Yes, sir.
Yeah. So that's very good. So you must be able to identify appropriate theorem to use at any point in time. So when you're done with it, let me know.
I'm done, sir.
All right. So I'll move to a new page. So I want you to try this. Question says find P, Q, R, and X in the diagram below. And here comes the diagram. Innocent diagram like that. Make sure your own are straight lines. No, I'm not using any two here. A, B, C, D, E. So you have here 89 degree. We have here angle S. You have here angle Q. You have here 49. You have here 36. And you have here R. Okay, maybe let me use another color for that R. Let me use another color for that R so that you'll be able to distinguish from that correctly. So this is R, the whole of that place. So you have here P. Yes, P, Q, R, S. Yeah. So I want you to lay your hand on this quickly. And let me see how you are faring. Note that you are going to use more than a theorem. Or let me say, use appropriate theorem. Are you making attempt?
Yes, sir.
All right.
Sir, you know angle A. The one after 89, what angle is that one?
You mean this place? Look at my cursor. You mean this place?
Yes, sir.
This is S. And here is 89 here. So this small angle here is S. Then this small one is Q. Let me clean it so that it will appear properly. Hope you are making progress.
Yes, sir.
Okay.
Okay. Okay, so
You are done.
I'm just about to finish.
Okay.
Something about art. What type of yeah. Wait, I should sing called one more. Jessica 36. And mm, 51. I'm done, sir.
Okay. Who is telling you the answer? Oh, you are speaking to yourself.
No one.
Okay. Yes. What is P? What do you
Um,
get for P?
I got for P. I got 131.
Okay. What do you get for R?
R. I got 55.
55?
Yes, sir.
That's wrong. Yeah, move on. What do you get for S or Q?
S. S. I got 36.
That's also wrong. What do
Ah,
you get for Q?
49.
Your P and Q are correct. That's good. Your P and Q are correct. I already know what is responsible for that. Now let me pick another color to show you something. Let me pick blue. Now, in my remark before we see example, I told you that it is possible to have two quadrilateral embedded in a circle. So I want to show you one now. That's why I want to trace it out with blue. Can you see that? Okay, let me start from A. A to C to E to D to E back to A. That's one. Hope that is clear.
Yes, sir.
But because I've changed my pen, that is why it's doing that. Can you see that? Hope you
Yes,
understand
sir.
what I try to trace out.
Yes, sir.
So that's one quadrilateral. Oh, we have 10 minutes. Now, if you now, let me now say that consider let me change the pen. It's not giving me what I want. Okay, so consider, now look at the blue that I've traced out. That's A, C, D, E. A, C, D, E. Can you see that? So that's one quadrilateral. So if I consider that, so I'm going to say P plus 49 equals 180 by what now? The theorem that we are using. What's the theorem again?
The theorem is
Opposite angle.
angle equals 180.
Opposite angles in cyclic quadrilateral. You get that now, sum to 180. So P will now be 180 minus 49. And that gives what?
131.
131, which is what you obtain for P. Now, by similar argument, you will see that R extend to that blue. Do you understand that now? So that will now give me that R plus 89 equals to 180. That is opposite angles in cyclic quadrilateral. So that will now be R equals to 180 minus 89. So that gives what? 180 minus 89.
180 minus 89, that is 91.
91. Very good. Now, let's now consider the red line now. Let me pick another color so that you be abreast of it. Let's look at green. Let's pick green. So I will move from A to B, B to D, then D to E, then back to A. So in that sense, now I can say consider A, B, D, E. So if you consider A, B, D, E, now opposite to angle B is going to be angle E in that context. Can you see that now? Do you get that? So
Yes,
P
sir.
plus Q will now be 180, opposite angle in a cyclic quadrilateral. And we have obtained your P to be what? 131. So that will be 131 plus Q equals 180. So Q will now be 180 minus 131. Yes? 180 minus 131.
It's 49.
49. Very good. So Q is 49. Then opposite, you can see that S will now go with 39 to form the whole angle you have in A. Do you understand that now? the whole angle you have in A will now be 89 plus S. And that will be directly opposite angle D here, which is 36. Does that make sense to you now?
Yes, sir.
Yeah. So I will now say that 89 plus S as one angle plus 36 equals to 180. Also, you say opposite angles in cyclic quadrilateral. So that will now be S equals to 180 minus 36 minus 89. Yeah, press your calculator for that. 180 minus 36 minus 89.
Minus 36 minus 89. 55.
55. So S is 55, Q is 49,
Oh,
R is 91. Do you get that now? Yeah, copy that quickly. We have 4 minutes left. So once you log out, just log in again with the details. So I will also admit you in. Hope that is clear to you now.
yes, sir.
Yeah. So when you are done writing, let me know.
I'm done, sir.
Okay. So that's that about that theorem. Opposite angle in a cyclic quadrilateral sum up to 180. Now, I've told you it does not matter the number of attached to the theorem. What matters is you knowing the theorem and when to use it. Is that clear?
Yes, sir.
So let's see another theorem. But we have approximately 2 minutes. Okay, I think we should be able to do one or two things. So theorem 8 now. Theorem 8. Let me quickly state that. This says two tangents drawn to a circle. Two tangents drawn to a circle from a single point. From a single point outside. Hope you are writing.
Yes, sir.
Okay. Outside the circle are of equal length. Are of equal length. Two tangents.
How many circle theorems are there?
How many what?
Circle theorems are there.
I don't get that. How many circle
Theorems are there.
that are there?
Yeah.
You mean from the theorem I just stated?
Sir?
From the theorem that I just stated, I said two
No, I'm
tangents.
like, how many circle theorems are there?
Oh, I think we are going to stop at maybe 10.
That's 10.
Maybe 10 or 9, I think. Okay, I think 9. So we are almost We're almost through with the theorems. Yes. So let's quickly look at this circle. According to that, so we are going to have a tangent drawn. Let me pick a line. So we are going to have tangent here. We are going to have another tangent here. So